Four massive AI tools just dropped this week. And honestly, the AI world barely had time to process any of them before the next one landed. We're talking about Unsloth Studio, a free local app that lets anyone fine-tune powerful AI models with no coding and 70% less memory uses. LiteParse, the open source PDF reader that AI agents have been waiting for. Baidu's Qianfan-OCR, a tiny 4 billion parameter model that just beat much larger models on key document reading benchmarks. And NVIDIA's Nemotron Cascade 2, an open model that just hit gold medal performance at the International Mathematical Olympiad, the International Olympiad in Informatics, and the ICPC World Finals. And the crazy part is, all four of these dropped within just a few days of each other. So let's talk about it. Let's start with Unsloth Studio because this one hit different for a lot of people. The whole premise of Unsloth has always been making AI training faster and cheaper. Their original library was already famous for cutting training times significantly. But the new studio release, which came out on 17th of March, takes things to a completely new level. They built a full no-code web interface that runs entirely on your own computer. No cloud, no subscription, no sending your data anywhere. You open the app, pick a model, upload your files, and start training. That's it. Here is the thing though. The numbers behind this are what make it actually impressive. Unsloth Studio trains over 500 different AI models at 2 times the normal speed and uses 70% less VRAM compared to standard training methods. That is not a small difference. VRAM is the memory inside your graphics card, and it is the main reason most people cannot train large models at home. If a model normally needs 24 gigabytes of VRAM, Unsloth might get it down to around 7. That opens up fine-tuning to anyone with a modern gaming GPU. They explicitly support NVIDIA RTX 30, 40 and 50 series cards, plus their new Blackwell chips and Intel GPUs. The workflow they build is genuinely well thought out. You start by loading a model, either downloading one from Hugging Face or loading something you already have saved locally. Then you create a dataset using what they call data recipes. You upload PDFs, CSV files, JSON files, Word documents, even plain text files, and the system automatically turns them into a proper training dataset. This is powered by NVIDIA's Data Designer, which runs underneath the whole pipeline. Once the dataset is ready, you hit train and a live dashboard shows your training loss, gradient values, and GPU uses in real time. You can even watch the progress on your phone. When training is done, you export the model to whatever format you need, whether that is GGUF for running locally with Ollama or llama.cpp or standard safe tensor format for uploading to Hugging Face. Now here is where it gets interesting. Unsloth Studio also has a built-in chat interface for running models. So you can use the same app to test your fine-tuned model right after the training. Compare it side by side against the original base model in what they call a model arena and see exactly what changed. The tool calling support includes self-healing, which means if a model calls a tool incorrectly, the system automatically tries to fix the mistake and retry. They also added full code execution, not just JavaScript like most chatbots, but Bash and Python too. And it runs offline. The whole thing works with zero internet after the initial install. And it even supports Claude Artifact style HTML execution inside the chat window, so you can generate interactive apps and run them right there inside Studio. The funny part is that this is still in beta. They're pushing daily updates. Windows support just got fixed during launch week, and Mac training via Apple Silicon's MLX framework is coming very soon. AMD GPU support is also on the way. Developers who used to need a cloud GPU rental and hours of setup can now fine-tune models on their home machines. That is not a small shift. Moving right along to LiteParse from LlamaIndex. And this one solves a problem that every developer building AI agents has run into at some point. Your AI agent needs to read a PDF, right? Sounds simple. But here is the reality. Most existing tools are either very fast but wrong, like PyPDF which just yanks out text with no understanding of layout, or very accurate but require cloud services, large models, or GPU hardware to run. Neither is great for an agent that needs to read dozens of documents quickly and keep moving. LiteParse takes a completely different approach. Instead of trying to detect tables and convert them to Markdown like most tools do, it preserves spatial relationships. It projects the text onto a grid that keeps the columns, spacing, and reading order intact. And because large language models are already trained on ASCII tables, code indentation, and structured text, they can read this format without any spatial conversion. The crazy part is how clean the output looks compared to PyPDF on the same document. PyPDF often smashes columns together or loses formatting entirely. LiteParse keeps the structure readable. It works as a command line tool and as a TypeScript native library. One line install and you can start parsing any PDF immediately. It handles offline documents too, including docx, XLSX, and PPTX files by converting them to PDF first using LibreOffice, then running the same spatial parsing pipeline. Images in PNG and JPG format are also supported through ImageMagick. OCR is built right in using TeaserAct.js, and it automatically runs across all your CPU cores in parallel for larger documents. If you need higher accuracy, you can point it at an external OCR server. They include example servers for parallel OCR and easy OCR out of the box. The benchmarks they ran are interesting because they could not use existing OCR benchmarks since those are designed around different output formats. So LlamaIndex built their own benchmark pipeline. They used a language model to generate question and answer pairs based on document screenshots, manually checked the dataset, and then run all parsers through the same questions using LLM as a judge scoring. LiteParse came out on top against PyPDF, PyMuPDF, and marked it down in both answer accuracy and parsing speed on large documents. They were careful to note this is not competing with cloud tools like their own LlamaParse, which uses vision models for much harder documents. LiteParse is the first local tool for agents that just need to read quickly and move on. In fairness, it does not do everything. Complex tables with merged cells, scan documents with very low quality, or layouts that require understanding of visual design rather than just text position will need a heavier tool. But for the massive percentage of agent workflows that just need clean text from normal PDFs, this fills a genuine gap. Now, here is where things get really competitive. While both of those tools were dropping, Baidu quietly released Qianfan-OCR, and it immediately started beating much larger models on document understanding benchmarks. This is a 4 billion parameter model, which is genuinely small by modern standards. Most serious models you hear about are 30 billion, 70 billion, or larger. But Qianfan-OCR just took first place on multiple document benchmarks, and the models it beat are not exactly lightweight. On OmniDoc Bench V1.5, which is one of the main benchmarks for real-world document parsing, Qianfan-OCR scored 93.12. DeepSeek OCR V2 scored 91.09, and here is the one that got everyone's attention. Gemini 3.1 Pro, Google's powerful multimodal model, scored 90.33. A 4 billion parameter model from Baidu just beat Gemini 3.1 Pro at document parsing. On OCR Bench, the score was 880, ranking first among all tested models. On OLM OCR Bench, it scored 79.8. Again leading the end-to-end model category. On key information extraction benchmarks, the model hit an average score of 87.9, beating Queen3 VL235B, which is a 235 billion parameter model. Meaning, Qianfan-OCR at 4 billion parameters is outperforming something with nearly 60 times as many parameters on these specific tasks. Now, to be clear about the win, this is not a blanket claim that Qianfan-OCR beats Gemini 3.1 Pro at everything. On some benchmarks like DocVQA and TextVQA, Queen3 VL4B still outperforms it. This is a highly specialized model built specifically for document intelligence, and in that lane, it is genuinely best in class. The forming here is important. The technical reason it performs so well at this scale comes from something they call layout as thought. Before producing the final text output, the model goes through a thinking step where it figures out the layout first. It identifies bounding boxes, understands where different types of content sit on the page, determines the correct reading order, and classifies each element. Then it uses that understanding to generate the output. The bounding box coordinates are stored as specified tokens rather than written out as numbers, which cuts the thinking output length by about 50% compared to writing out actual coordinates in plain text. There is also practical speed improvement with W8A8 quantization, which is a way of compressing the model's numbers without losing much accuracy. Qianfan-OCR runs at about 1.024 pages per second on a single NVIDIA A100 GPU. That is a 2 times speed up over the uncompressed version. And because it runs entirely on GPU rather than using a mix of CPU and GPU like older multi-stage pipelines, you avoid the bottleneck that happens when data has to move between the two during processing. One area where traditional two-step pipelines fail completely is chart understanding. The two-stage approach is where you first run a text extractor and then pass that text to a language model. That workflow scored exactly 0.0 on chart-safe benchmarks, because the text extraction step throws away the visual context that tells the model where data points are, how axes relate to each other, and what the chart is actually saying. Qianfan-OCR processes everything together and preserves that context, so it can actually answer questions about charts. The model is fully open source, available on Hugging Face and GitHub, which means anyone can run it locally, fine-tune it, and build it into their own product. And then NVIDIA dropped Nemotron Cascade 2, which is the most technically dense of the 4 releases, but also the one with the most impressive benchmark story. This is a 30 billion parameter mixture of experts model, meaning it has 30 billion total parameters but only activates 3 billion of them at a time during inference. That is important because it means the model runs much faster and uses much less memory than a dense 30 billion parameter model, while still having the knowledge and capability of a much larger system. The benchmark that really got people talking is that Nemotron Cascade 2 is only the second open-weight model in the world to achieve gold medal performance at all 3 of the most prestigious technical competitions at once: the International Mathematical Olympiad, the International Olympiad in Informatics, and the ICPC World Finals. The first was DeepSeek V3.2 Speciale at 671 billion parameters. Nemotron Cascade 2 does it with 30 billion total and only 3 billion active. NVIDIA themselves describe this as 20 times fewer parameters than DeepSeek, achieving the same level. These comparisons are not simple tests. The IMO is where the best high school mathematicians in the world compete with problems that PhD mathematicians find genuinely hard. Hitting gold medal level at all 3 as an open model at this size is something that was not possible even a few months ago. On AIME 2025, which is the main American math competition benchmark used by AI researchers, Nemotron Cascade 2 scored 92.4 compared to Quen 3.5 35B, A3B's 91.9. On 8 MMT February, the score was 94.6 versus 89.0 for the same competitor. Coding performance is even more striking. On live Codebench V6, it scored 87.2 against 74.6 for Quen 3.5 35B A3B. On IOI 2025, the Competitive Programming Olympiad test, the score was 439.28 versus 348.6. For instruction following on Arena Hard V2, it hit 83.5 against 65.4. That is an 18-point gap. The training method behind this is what NVIDIA calls cascade reinforcement learning. Instead of training the model on everything at once. They do sequential domain-specific training. Math reasoning, coding, instruction following, and software engineering all get their own reinforcement learning stage. Each stage is stewed separately, so improving coding does not accidentally hurt math performance. They also use something called multi-domain on-policy distillation, which is a way of using strong intermediate versions of the model as teachers for the final version. On AIME 2025 specifically, this method reached teacher-level performance of 92.0 accuracy in just 30 training steps. The standard GRPO method only reached 91.0 in the same number of steps. Faster learning, better final result. The model supports both thinking mode and non-thinking mode, which you can control through the chat template. Thinking mode starts with a single think token in the assistant turn. Non-thinking mode uses an empty think tag pair prepared at the start. For agentic tasks, it has a structured tool calling protocol built into the system prompt design. The whole thing is fully open weight and available on Hugging Face right now. Now here is what is interesting about this week as a whole. All 4 of these releases are open source. Unsloth Studio lets anyone fine-tune at home. LiteParse makes PDF reading free and local. Qianfan-OCR puts specialized document understanding in the hands of anyone with a GPU. And Nemotron Cascade 2 gives researchers access to gold medal level math and coding reasoning without needing to pay for a closed API. In fairness, there are still limitations across all 4. Unsloth Studio is still in beta and AMD training support is not there yet. LiteParse struggles with very complex layouts that need visual understanding. Qianfan-OCR is highly specialized and not a general purpose model, and Nemotron Cascade 2, while impressive at math and code, is not claiming to beat the best models across every possible task. The honest story is that each of these solves a specific problem extremely well rather than trying to do everything. That's where we will wrap it up. The question I keep coming back to is whether open source tools releasing at this pace changes what individual developers can build without any cloud budget. Drop your thoughts below, make sure you are subscribed, hit the like button, and I will see you in the next one.